A raft foundation of 30 meter by 25 meter is proposed to be constructed at a depth of 8 meter in a sand layer. So you remember that this is constructed in a sand layer, and a 25 meter thick saturated clay layer exists 2 meter below the base of the raft foundation. Below the clay layer, a dense sand layer exists at the site. So this is all about the site part. And then a 25 thick undisturbed sample was collected from the mid depth of clay layer and tested in a laboratory odometer under double drainage condition. It was found that the soil sample had undergone 50% of consolidation settlement in 10 minutes. See, this is all about the laboratory. 25 thick undisturbed sample is tested and it has gone under 50% of the consolidation settlement in 10 minutes in the laboratory. Now this is the laboratory information, this is the site information, and then the question is the time in days required for 25% consolidation settlement of the raft foundation will be how much. So let us understand the question first. Okay, see, raft foundation a raft foundation of 30 meter by 25 meter. So generally raft foundation is a combined footing for all the columns in a building or in a structure. Suppose there are number of columns. Okay, so you can go through the Google or any book what is to know about what exactly is the raft foundation. It is just a foundation, a combined foundation for all the footings. Okay, so this foundation is raft foundation, this one, so this is the width or this is the length, like that. So anyway, so let us say this is 30, this is 25, this is a rough information anyway in terms of diagram. So this is proposed to be constructed at a depth of 8 meter in a sand layer. So what do I do? First, for your understanding, I will draw. Okay, like this. So it is to be constructed at a depth of 8 meter. So this is 8 meter, it should be constructed at this depth. Okay, so there are number of footings, number of columns, there are many number of columns anyway. So here again a 25 meter thick saturated clay layer exists 2 meter below the base of the 2 meter below the base of the raft foundation. This is the base, okay, and below that 2 meters below that, so let the clay layer starts. Okay, so this is existing in which soil? This is sand, and below that there is a clay layer. Okay, this is clay. Now what is the thickness of the clay layer? 25 meters. So anyway, this is not up to the scale. You may think that this is 8 meter, this is 2 meter, it cannot be 25 meter, but it is not to the scale, but it is okay. Let us consider this is 25 meter. Okay, so this is clay layer. Now below that clay layer, again below the clay layer a dense sand layer exists. Okay, this is again dense sand layer. Okay, it is not mentioned in the question what is the depth of the dense sand layer below this. It doesn't matter then. So what is happened then? A 25 a small sample compared to 25 meter. 25 is very small. Thick undisturbed sample was collected from the mid depth and tested in a laboratory under double drainage condition. I'll explain what is the double drain condition. It was found that soil sample had undergone 50% of the consolidation settlement in 10 minutes. See, this is TL, means lab, because of that I am writing TL, and this is percentage of the consolidation, I will denote it by U. Okay, this is UL, and double drainage condition it is. So anyway, so let us write down the given data. what is the given data? In laboratory, thickness of the sample is 25 mm and time for 50% consolidation is 10 minutes. Okay, and consolidation amount is 50% of the consolidation is done. Next, so drainage condition is double drainage condition. Double drainage condition. So yeah, now see, whenever, let us say this is the clay layer. Okay, now when there is a consolidation happening, suppose this is sand, this is rock below, okay, this is sand above. So whenever we are trying to consolidate by applying the pressure, so the water which is existing in this clay, that tries to go up because sand allows water to drain out, whereas rock does not allow. So what is this then? So drainage path is not double drainage condition. The condition is only single drainage condition. It is happening only from one side of the clay. Suppose there is, instead of rock, let us say there is sand, then the water can go in both ways. Okay, this is called double drainage condition. So what is the significance of the double drainage condition or single drainage condition? Let us say this is the height of the clay. Okay, now in double drainage, any water particle you take, the maximum length which is travelled by a water particle in this clay will be half of this height of the clay in double drainage condition, because which is at the middle it can go anywhere, but which is above the middle point it will travel above, because this is the lesser distance compared to this is compared to the downward direction. So that's why. And if it is here, the water particle will move in this direction in this case, because it is nearer to this drainage, this sand. So anyway, the maximum distance which is travelled by a water particle in the clay sample in the double drainage condition will be h by 2, which is denoted by small d generally. So in the single drainage condition, d will be h, because suppose there is a rock, so this is single drainage. Now water particle here also should move total length. So that is how the drainage path, d is drainage path, that should be equal to h in single drainage, h by 2 in the double drainage. So here, so this is the height of the sample. Okay, HL will write. So what is DL now? As this is double drainage, okay, in the question it is mentioned, then HL by 2, 25 mm by 2 equal to 12.58 mm. So we know DL, we know U, we know T, which is 10 minutes. Now we will talk about Terjaghi's one-dimensional consolidation theory. Okay, see here, when the consolidation is happening due to in one direction, due to the expulsion of the water only in vertical direction. If it is happening only due to vertical traveling of water or vertical expulsion of the water, and it is happening only due to the expulsion of the water in only vertical direction, that is the reason why one-dimensional consolidation it is called. Okay, so there is actually three-dimensional consolidation which happens in the field, but this is one of the assumptions in Terjaghi's one-dimensional consolidation theory. So while deriving consolidation parameters. By taking Terjagi's one dimension consolidation theory, we will get the partial differential equations while deriving that, and the solutions which we have to focus on mainly will be introduced with two terms while deriving the one dimensional consolidation theory equation. We will be getting two terms. One is CV, which is K by mv into gamma w. Another one, time factor, CVT by d square. So these are the two factors which we will get during the derivation of the consolidation equation, one dimension consolidation equation. You can go through any book, K.R. Arora or Gopal Ranjan. Books, these are books. You can go through the consolidation equation. Okay, so in that you will be coming. And what is CV? CV is coefficient of consolidation. Okay, and MV is coefficient of volume compressibility. Okay, and TV is time factor. And T is time for consolidation. So D, I have told you, D is drainage path. Anything else? See, K is permeability of the soil, whereas gamma W is unit weight of water or pore fluid, whichever is there in the soil. So now these two terms are introduced while deriving the equation. Now we will understand the significance of the these parameters. CV, CV is constant for a soil, constant for a particular soil. Okay, whereas time factor changes according to the time. See, there will be consolidation happens from 0 to 100%. So if you take 50% of the consolidation, the time required for the 50% consolidation will be T50, then it will be TV50, like T20, 20% of the consolidation, TV20, like that. So here D is constant, CV is constant. If T, small t varies, capital T also varies. Okay, now so these are the terms which are introduced, and now we will understand. Sorry, let me take a minute. Yeah, coming back to so here time factor, there is a formula for time factor, TV equal to, you can find out by using this U by, see, where U is percentage of the consolidation. So this formula is applicable when percentage of the consolidation is less than 60%. Okay, when the percentage of the consolidation is less than 60, then you can use this formula, pi by 4 into U by 100, where U is in the percentage. So you will get the time factor. Now we are using only this formula. When U is greater than 60%, greater than 60%, you can go through those books. Okay, now so here we will take the lab conditions. We can, U is 50%, then we can find out TV at the rate 50, time factor pi by 4, 50 by 100, here square will be there, 52, so pi by 16. So TV is pi by 16. Now we know TV is also CV T by D square, correct? Now time factor does not have any units, because see, this is percentage does not have any units. That's where TV does not have any units. Now by using this formula, what I'll do, I'll find out CV, right? How? TL, TVL. Okay, now what is CV? CV is constant for a soil, whether it may be in lab or it may be in field. Okay, now TVL into D square divided by small t into L. So what is CV of the soil? TVL pi by 16 into D. D is how much? We have D is H by 2, where H is 25 mm. That means 25 into 10 power of meters divided by 2. Okay. So TV is then D square TL 10 minutes. So let us convert it into days. So 10 minutes in days, if I have to convert, so what I have to do is 60, if it is multiplied it will be in terms of hours, then 24, so that it will become in days. Okay, so finally units will be meter square by days, because this is meter square, this is days. So can we find out? Let me calculate using Calc. So this one is 4.41786 into 10 to the power of minus 3 meter square per day. Okay, now we know the CV. Then what is asked in the question? We have to find out time required for 25% of the consolidation settlement of the raft foundation will be. So in the field they are talking about. Now in the field U is 25%, so then this is about the field. Then TV you can find out pi by 4, 25 by 100 square, then 25 4 the pi by 64. You got the TV value, then you know the CV value from the previous calculations. If you see the formula, CV T by D square, where D in the field H field by 2. H field is 25 meter, clay is of 25 meter depth. So 25 meter depth divided by 2, so 12.5 meter. Now because it is double drainage in the field also, why? there is a sand above and dense sand below. Though it is dense sand or loose sand, that is permeable. So that is the reason why drainage can happen. So now taking this TF and TVF, what I'll write, pi by 64 equal to CV. CV is how much? 4.41786. 4.41786 into 10 to the power of minus 3 into TF. Time required in days we need to find out. Okay, D square 12. So if you substitute all these TVF values and CV value from the previous calculation and TF and D from here, so then TF will be from this, you will be getting 1736.11 days. Okay, so this is the answer. Thank you.